Welcome to Auto 155, Electricity and Electronics 1. My name is Tony DeBlasi, and in this lecture I will be covering battery testing and service. This is part 1 of a 2-part lecture based on Chapter 51 from the Automotive Technology, Principles, Diagnosis, and Service 6th edition. For additional information on this topic, please read this chapter and refer to the PowerPoint found in the course content folder. Please note that there are both audio and visual lecture attendance codes scattered throughout this lecture. Please write these codes down as you see and hear them. At the completion of this lecture, you will be required to go to the assignment folder and take the online lecture attendance quiz in order to get credit for attending this lecture. The following is an overview of the objectives covered in this lecture. I will list the precautions for working with batteries. I will discuss the symptoms of a weak or defective battery. I will discuss how to inspect and clean battery terminals and hold downs. I will discuss how to test batteries for open circuit voltage and specific gravity. I will describe how to perform a battery load test and a conductance test. I will explain how to safely charge and jumpstart a battery. I will discuss how to perform a battery drain test, and I will describe how to prevent loss of memory functions and reinitialize memory functions. I will even demonstrate how to install a battery. The information found in this chapter will help you prepare for the ASE Electrical Electronic Systems A6 Certification Test, Content Area B. When working around automotive batteries, extreme caution must be used. Batteries contain caustic sulfuric acid that can burn skin and cause serious damage to eyes. It can also damage clothing and painted surfaces. The noxious gases released from batteries can be harmful to breathe and are very explosive. This alone means that all sources of ignition must be kept clear of a battery. I want to play you a video of a person who decided to test the volatility of a battery's explosive gas. In this video, the person is placing a conductor between the positive and negative terminal, creating an arcing spark. Watch what happens when the hydrogen sulfate gases ignite.
Not doing anything. Oh.
Look at my face, is it fine?
Yeah, is mine?
Yeah. Okay. Oh!
That's all that's left over. Boy, that hurt a lot. Acid everywhere. God damn.
Let's watch the actual explosion again in slow motion. Imagine what this would feel like if your face was right there and you weren't wearing safety glasses. Chapter 51, Lecture Code Question Number 1. Make sure to write this down. 33987. Once again, that is 33987. Please write this down. So obviously there are safety considerations. You want to make sure that you're disconnecting your negative battery cable first whenever you're working around a battery. That ungrounds it or takes its ground away. You also want to make sure you're wearing eye protection. Goggles are obviously preferred. Sometimes a face shield is preferred. You want to make sure that you have protective clothing on and avoid skin contact with battery acid. And if you get any battery acid, and even solid battery acid on your clothing, you want to make sure that you wash that with baking soda immediately. Otherwise, it can actually eat the fabric of your clothing. You want to adhere to, obviously, the safety precautions and service procedures for equipment used for battery service and testing. Never smoke or use any type of flame around a battery. That could be a problem. That could cause that thing to explode, as we just saw. There are warning signs when you're working around a weak or defective battery. The warning signs would be low water. If you were able to actually open the battery up and see inside, you'd notice that there's low water. If you can see the plate material, then the water's not there. Excessive corrosion is a good indicator. Slower than normal engine cranking could possibly be a defective battery. It could also be bad wiring too. Odors, such as rotten egg smell. That's something you want to be cognizant of. Obviously, case swelling as well. That's not good. Here's an example of a cap that's been removed from a battery, and you can actually see the plate material inside. That means that the water's low. It needs water added to it. And the only type of water that you would add is distilled water. You don't want to have tap water because that has minerals, and that will effectively destroy that or ruin the battery, shorten the life dramatically. Here's an example of a dirty battery terminal. There is a good potential that there could be corrosion between the terminal and the post as well, and that it could also grow up into the wire, causing a voltage drop or excess resistance in the wiring. In this example, kind of highlighted the relationship between the post itself and the terminal. You want to remove this and actually clean the post itself. This is a good example of some chalky residue that was actually creating a voltage drop. And this is a before and after we clean that. So it's always a good idea to clean that. You want it to be nice and bright. And you also want to clean the inside of the terminal itself. Here's an example of a dirty battery case. Dirt itself contains conductive material. So in this example, I have a meter that's not a snap-on meter, but you can see in these examples, I'm connected to the positive terminal with one clip, and my negative lead is just touching the dirt on top of the battery, and it's giving us a voltage drop, an extension of that negative terminal. There is the positive terminal attached here, and there's your dirt right around the vent cap, causing a 7.91 volt drop. This is the most dramatic one of all, where this is considered, right where I am here, is considered an extension of the negative terminal, and I'm able to provide 8.28 volts. So essentially, if I see voltage like this, that means that this battery is slowly discharging through the dirt on top of the case. So here's our dirty battery, here's a clean battery. So take the time to clean the actual case. You may have to remove the battery from the vehicle. Don't take a hose to it because we don't want to get, tap water down inside of the vent caps, but take your time and really wipe it off, clean it off really well, and clean those terminals up the best you can. Now, as far as frozen and swollen batteries go, if we have a frozen battery, that means that the sulfur that's inside the sulfuric acid is now clinging to the plates, leaving water left behind. When that water is left behind, it can freeze, and that frozen water will then expand due to the air pockets that also contain a large amount of hydrogen, which makes this extremely dangerous to jumpstart. They're essentially little bombs that can blow up, so we want to be really careful. Whenever we see swollen batteries, we want to definitely be extremely vigilant. Here's an example of a swollen battery, and you can see the case is swelling at each individual cell. This is extremely dangerous, and there are vent plugs too. This could have been a battery that wasn't allowed to vent, causing it to swell in this manner. When you see that, that needs to be replaced, period. There's no saving that. If you did have a frozen battery and you were able to thaw it, the plates themselves will become warped inside, and they could actually be touching, and they can actually short out a cell, and that's not good. So anytime a battery is frozen and it's confirmed frozen, you actually witness the swelling, it needs to be replaced. Now, as far as maintenance goes, the need for maintenance, most of your new style batteries are maintenance free, so there's really no need to maintain them other than cleaning them like we talked about. The reason for this is they use a lead calcium mixture in the plate material instead of the old style, which was lead and antimony. That would cause more gassing. Basically, they don't gas as much anymore, so a lot of your new style batteries aren't necessarily a maintenance item. Cleaning battery terminals is important. You want to, it says here to use baking soda. I'm usually going to use a commercial cleaner, but baking soda works great. It will work. And this is saying use 1 tablespoon of baking soda to 1 quart or liter of water to neutralize. Normally what I'll do is I'll dump in baking soda and make it kind of pasty. I'll show you a picture in a second. And the hold down, obviously we want to make sure that the hold down bracket is snug. We want to make sure that it can actually clamp that battery down. You want to be careful too with hold down brackets that you don't over tighten them. They can get pretty rusty and sometimes need to be replaced as well. In this example, there is a battery. There's a plastic spoon, which is smart because we don't want to arc anything. But if you make like a paste, you can smush it in there and really kind of work it around. I'll use it like an old toothbrush to work it in. You want to be careful though. The reason you want to be careful is you don't want this solution to end up inside the vent caps of the battery because that will actually neutralize the battery. So if I have a terminal that's full of corrosion, I'll remove the terminal and I'll actually put the terminal inside a cup of water and baking soda solution. So that way it can work its way into the actual terminal and get to those hard to reach areas. If you have a significant amount of corrosion on this terminal, it might be worth replacing it completely. And by that, it might not be just the terminal, it might be the actual cable itself. The aftermarket replacement terminals are not usually recommended for a good factory repair. They actually want you to replace the entire cable. And it might be worth doing because if that cable does have corrosion in it, that will create a voltage drop due to the resistance in the cable. So you could put all the fresh batteries you want, it won't make a difference. So the big problem could actually be, or the bigger problem could actually be the cable. Chapter 51, Lecture Code question number 3. 781123. Once again, that is 781123. Please write this down. I'm going to play you a video that demonstrates how to clean battery terminals. Before we remove the terminals from the battery, I'm going to show you how I hook up Keep Alive memory to provide a backfeed of battery voltage to the vehicle's electrical system so that we can maintain memory. Once that's done, we can remove the terminals from the battery. So here's the alternator's BAT or B nut. We're going to attach a red jumper lead to that. The other end of my red jumper lead is going to be attached to my fender cover. I'm going to remove that, and I'm going to put that onto an external power source. In this case, I'm using a jump pack that's on the ground. I'm going to connect a vice grip to a chassis ground. I'm going to snap another jumper wire onto that and connect it to the negative side of my jump pack. And then I'm going to spray some commercial cleaner into a rag. And I'm going to work a toothbrush in. And I'm going to cover it onto the actual terminal. And work it in. And you can see it working right away. It's neutralizing and cleaning the acid off of the terminal. Once that's clean, I'll bring in a ratchet, loosen the terminal, remove it, and you can actually see how the corrosion has built up inside the terminal itself. I'm going to go ahead and use a gear tie and pull that off to the side so it's not in the way. Now I'm going to go ahead and remove the positive terminal, supporting the terminal itself with my hand while I actually loosen the fastener. As I remove the terminal from the post, you'll actually see a lot of the corrosion start to fall out of the terminal connector itself. Work in some more cleaning material. I'm actually going to take a mechanical brush and scrape down a bit of the lead post. And right here I'm scrubbing away at the actual inside of the terminal so that the two surface areas will be nice and clean, metal on metal, no corrosion. Reattach it. Once again, supporting the terminal with my hands, snugging it. Not too tight, but tight enough. I'm going to go ahead and scrub out the inside of the terminal on the negative side, and you can actually see the material flying all over the place, which is why you want to have safety glasses on. This is an example of how you can just completely submerge the terminal into the cleaning agent. You can also do that with a cup full of baking soda and water, using the brush to clean, to get into those hard to reach areas. Then we reattach. I'm going to then remove my Keep Alive memory from both the negative and the positive. Now, as far as state of charge goes, we've discussed earlier in the semester how you can test this with a voltmeter. Very, very easy to do, often referred to as an open circuit voltage test. If you have a surface charge, it may need to be removed before you do the test. So anything over 12.6 volts typically could indicate a surface charge. So that means that the vehicle is maybe running prior to you testing it. So turn on the headlights for 10 to 15 seconds and burn it off before you do your test. So this would be a typical cell, and obviously this isn't what a real cell looks like, but imagine on one side you have a bucket or a tube that's full of water. On the other side you have a tube that's empty. So essentially you'd have a full tube on one side and an empty tube on the other, creating a potential, right? So if these were connected through a little tube, anything pushing on that would create a force, right? So imagine those buckets of water. So we have a cell that's 2.1 volts. We have a total of 6 cells connected in series, so the positive plate will be connected to the negative plate and so on, which will add up to become a larger battery. So we're essentially using 6 little batteries to create a larger battery. And our overall voltage on the outside, we would put a meter on this and it would give us that 12.6 volts. That would give us our state of charge. Now that doesn't mean state of health. That means state of charge. You could take 2 9-volt batteries and connect them in series and they cannot start a vehicle because it doesn't have the amperage. It doesn't have the capacity. So this is a good indicator when you're first starting out, especially if you have a vehicle that's been just taken into your bay or into your shop. You can quickly check the voltage, and if the voltage is low, you might want to put a charger on it before you do any other types of diagnostic, especially when it comes to looking at your starter or looking at your alternator. It's always good to work with a battery that's fully charged. So here's an example of a meter connected. On meter on the left is showing the A example, a battery that's under 75% state of charge, because 75% state of charge would be 12.4. Meter on the right is a fully charged battery sitting at 12.6 volts. So here's our battery charging chart, or I should say our state of charge chart, pretty much indicating the steps. And the way that I've always taught this and learned this myself was 12.6 volts gives me 100% state of charge. For every 0.2 of a volt that we drop a full 0.25% state of charge. And this is saying here 11.9 or lower. I've pretty much said 11.8 or lower because it sticks to that 0.2 of a volt drop rule. As far as hydrometer testing goes, using specific gravity, we've discussed this in the past. Temperature matters. In this example here, we're dealing with a battery at 40 degrees. We actually have to subtract 16 from our specific gravity for our corrected specific gravity. And in this example, this is at 100 degrees. Ideally, you want 80 degrees Fahrenheit. So if it's too cold, you have to deduct. If it's too hot, you have to add. So this isn't a perfect science. But once again, we're not going to do a lot of testing with a hydrometer because these batteries are maintenance free and you're not going to be able to get inside anyways. So we're going to be doing different types of testing. But here's your hydrometer. This is what the actual little gauge looks like on the side. And these are your settings. You may be asked this on your ASE test. I know I was. They still like to ask this question, so you should have an understanding of what your specific gravity is, at least. As far as load testing goes, nothing beats a load test because you're actually putting a physical load on the battery and you're putting it under a strain. So load testing is great, but you want to make sure that the battery is fully charged before you do a load test. In this example, I want to make sure that my 600 CCAs is what this battery can put out. So I want to test it at 600 CCAs when I do my load test. And this is an example. This is a snap-on tester that can actually put a physical load, a carbon pile load on that battery to truly tell. Now, this is the frequently asked question from the book, and essentially it's talking about dual battery applications. There's 2 styles. There's the one you're going to see a lot of the time, which is like a pickup truck, like a plow truck that has 2 batteries installed in parallel. And we'll get into this in a second. And then you might have a vehicle that comes in like a heavy-duty truck or a bus or a tractor or something. And they have their batteries connected in series. Either way, to successfully test the battery, or the batteries, plural, they should be disconnected from the system and tested individually, separately, to verify which one's actually bad. Now, if one of them is found to be defective, the industry norm is you should replace both of them. In this example, this is a diagram of 2 batteries that are actually connected together in parallel. So you can see the negative of one is connected to the negative of the other, and the positive of one is connected to the positive of the other, giving me an overall voltage of 12. However, we do add the CCAs of both batteries. So these 2 batteries, the benefit is connected in parallel, they can actually provide a 1,000 amp cranking capacity to that starter on a really cold day, which makes it ideal for diesel applications and, trucks that maybe have a higher, I say trucks, but like a plow truck with a sander in the back and lights on the roof and radio equipment, like a service truck. Now in this example, you have the 2 batteries connected together in series. So your positive and negative posts are connected. The benefit here is you end up with higher voltage, but your amperage stays the same. So that's the difference. You don't see this very often. One could argue that the actual battery in your vehicle is made up of 6 individual 1.2 volt cell batteries. This is kind of the king, conductance testing. Conductance testing is done with typically a Midtronics tester. This is pretty much the standard in all of your shops now. This is designed for warranty. So as far as whether or not you're going to cover that battery under warranty, it has to have a conductance test done on it. So essentially, you would enter the correct unit to the battery, being CCA, or it could be EN for European norm, or it could be SAE, Society of Automotive Engineers. There's different numbers you can use, but typically CCA is the one we're always going to use. And the tester will basically give us a result. And this is the Midtronics tester. This is an older tester, but they're still out there. You're going to set it up for the correct CCAs, and it will spit out what it can actually produce. They're pretty easy to use, pretty straightforward. Some of them can also measure temperature, which is great. You'll get more accuracy that way. As far as charging goes, you want to make sure that you're using the right charge rate. Essentially, that's the most important thing about battery charging. And I'm always going to say low and slow, but we don't always have that luxury. When you are charging a vehicle, you're going to have probably one of these shop chargers that wheel around. And in these, you can set both the actual charge rate itself, and you can also set a timer. That's what these dials are. So you want to make sure that whatever charge rate you choose, you set the timer as well. They do have a hold feature, so if you set it to hold, it will essentially pump out that amperage until you shut it off. So if you forget about it, that could be a big problem. So here's a good example. Here's a little chart here on the left-hand side. It shows you your state of charge, and then it also displays specific gravity. It also gives you a percentage state of charge, which we can do off of that other chart. And then it gives us at different amperage ratings what we can actually produce, or how long it will take us to bring that thing back. As far as side post batteries, when you remove them from the vehicle that they're installed in, the actual terminals themselves are flush with the case of the battery. So as far as side post batteries, you're going to have to use an adapter. And you want to use the adapter that comes with it. So here's an example of an adapter. You don't want to use steel bolts, because steel bolts can actually strip out the little lead thread linings. So you want to use these adapters whenever you're doing any type of charge with these. Very important that you do that. Now, as far as charge time goes, you can actually use the reserve capacity on the label to give you your time. So if I had a 90-minute reserve capacity and I was using a 10 amp charge rate, you would do the division and it would give you 9 hours. It would bring me back to a full state of charge based on a discharged battery. So in this example, if I had a 5 amp charge rate and I had an RC of 100, how long would it take me? It would take me 20 hours to bring that battery back. Just an indicator on how we can use RC to determine how long it would take us. Now, as far as overcharging goes, it's extremely dangerous. We want to make sure that you're using the correct charge rate, but there have been times where people have put batteries on a charger and forgot about it and walked away. One example was at our school, where the car was put on a charger set to hold, and it was basically forgotten about, and it caught fire later after the school was closed and caused obviously a big fire here. So just to show you the damage that can happen from leaving a battery on a charger and not taking it off. What's nice about this picture, nice I guess, is that you can actually see the battery and you can actually see the plate material inside. Here's another example of you can actually see the actual plate. And there's the alignment computer, melted keyboard and melted mouse. Pretty bad. Now, when it comes to jump starting, jumper cables or a battery box, the last connection should always be made on an unpainted metal ground or chassis away from the battery, as far from it as possible, to avoid the risk of a spark igniting that hydrogen sulfate that is leaking from that battery. A lot of your newer cars out there, especially your hybrids and your electrics, have a dedicated ground pin or ground nut made just for the purpose of jump starting. This is a jump pack that you can turn on or off, right? So there's a little switch here. Typically, I will always teach you should use your jump pack as if it doesn't have an on or off switch. So we're still going to connect it this way. Now, I'm going to show you a video of a jump start procedure. So in this example, what you want to do is you want to start by turning off loads. We want to turn off as many loads inside the vehicle as possible. We don't want to have anything on. The other thing we want to do is we want to disconnect plugs from any outlets. We don't want to have anything plugged in, like phone chargers or radar detectors or anything else. You also want to remove the keys from the vehicle so that it can't be started. Here, we're going to attach the positive clip from my jump pack first. If you don't have any room for a positive clip, you can actually use a vice grip or a locking pliers to give you the surface area necessary to do the jump start. And this is by design. I actually put it sideways across the locking pliers to give me a better grip here. Attach that. Now, as you come in for the negative connection, notice I'm using locking pliers on a strut tower bolt. I'm using it on the actual bolt, not the threads. Be very careful not to crush the threads. This is a really good way to create a ground for yourself. And when you make this connection, you want to be really careful. That's why we go away from the battery. You're going to see sparks. That's normal. And in this example, you can actually see how I caught the sparks in the video. Here it is, real time. So with the jump pack connected, now it's time to start the vehicle. If you have a switched kind, you'd switch it on. Now you want to make sure that you're stepping on the brake pedal when you do this. If it has a manual transmission, you also want to make sure you're stepping on the clutch. You're going to press the button or turn the key to start the engine. Don't rev over 1500 RPMs. Typically, a vehicle in open loop will obviously hit the 15. I know Toyotas will, very common. Don't go any more than that.
Chapter 51, Lecture Code question number 5. Please write this down. 87943. Once again, that is 87943. Please write this down.
After allowing the engine to run for a couple of minutes with your jump pack attached, it is recommended to turn on loads prior to removing your jump pack. We do this so that we can excite the alternator, get it turned on and cycling more often, so that when we do remove the jump pack, it doesn't create a spike to the system. And we do that, one example I'll use here in this video, is I want to turn on my HVAC blower motor on high. So I'm going to crank it right up here, and I'm going to turn on rear defrost if I can. That will really excite the alternator. Then I'm going to remove my negative clamp first, my positive clamp second, and then take out any vice grips or locking pliers that I had installed to make sure I clean up my work area.
This concludes the Part 1 lecture for Chapter 51, Battery Testing and Service. For additional information on this topic, please read this chapter and refer to the PowerPoint found in the Course Content folder. Now that you have completed this lecture and you have written down the online lecture attendance codes, please go to the assignment folder and take the online lecture attendance quiz in order to get credit for attending this lecture.